So DHCP protocol principles. DHCP stands for Dynamic Host Configuration Protocol, and it's mainly a protocol that is used to make network management easier at the enterprise network in our LANs. How so? DHCP is used to automatically assign network parameters to end devices. These network parameters are the parameters that the end devices need in order to be able to access the network or the internet, such as the IP address, excuse me, such as the IP address, stuff like the DNS server, the gateway IP address, and so on and so forth. So really, in this topic, that is what we want to look at and appreciate how it helps us manage the local area network. So an enterprise network may often consist of a substantial number of host devices, each requiring network parameters in the form of IP addressing excuse me, and additional network configuration information. Manual allocation is often a tedious and inaccurate business, which can lead to many end stations facing address duplication or failure to reach services necessary for smooth network operation. DHCP is an application layer protocol, application layer. So the next the next three protocols that we're going to look at are actually application layer protocols: DHCP, Telnet, and also FTP. So DHCP is an application layer protocol that is designed to automate the process of providing such configuration information to clients within a TCP/IP network. DHCP therefore aids in ensuring correct addressing is allocated and reduces the burden on administration for all enterprise networks. This section introduces the application of DHCP within the enterprise network. By the end of this chapter, you should be able to. A volunteer, please.
Describe the function of DHCP in the enterprise network.
Yes.
Explain the leasing process of DHCP and configure DHCP pools for address leasing.
Address leasing, wonderful. Who's this?
Joshua.
Joshua, asante sana Joshua. Okay. Now, as I said, DHCP stands for Dynamic Host Configuration Protocol. So you can assign network parameters to end devices statically or manually. So dynamic here means we are doing it automatically. Host end devices in a network are called host. Also referred to as host. Like here we have host A and host B. Configuration, these are some of the configuration parameters that we want to assign. And the most important one, of course, is the IP address, the most important configuration parameter that we might want to give. But in order for a computer to be able to access the internet, you might need things like the DNS server address. I think we saw this when we were doing the first lab. You might also need the gateway address in order for it to be able to access other LANs or VLANs or the internet. You also need the gateway address. So these are some of the other configuration parameters that a machine might need in order to be able to access the internet. Now, generally, you can configure these particular parameters manually on these end devices. You can configure manually. But now, manual configuration is saved with several challenges. So let's say demerits of manual configuration. Maybe some of you can guess some. What do you think might be the problem with doing manual configuration, especially if your LAN has grown and you're getting more and more end devices? what are some of the challenges that you think you might encounter if you go the manual configuration way? Anyone? Yes, Kichinda.
There will be IP address conflict. Yeah?
Exactly. So
Yeah.
it's actually prone to error. This error can lead to conflicts, IP conflicts. Sorry, IP conflict. Thank you. Any other disadvantage you think? Lynn, what comes to your mind when you think of configuring, for example, MMU now has 6,000 students. So let's say 4,000 have machines. If you were to do it manually, what do you think, other than being prone to error, what do you think the other problem is?
It involves a lot of work.
Exactly.
Tedious.
Exactly.
Yeah.
Gadudi, you had raised your hand.
Consume a lot of time.
Exactly. Time consuming. Prone to error. We've already said that, and it's not just doable. So most of the time, you'll have a server in your network that is responsible for issuing these particular parameters to end devices. So DHCP actually provides a client-server architecture where your end devices in your network can request for an IP address, and the server can assign an IP address together with other parameters to end devices in your network. So that automatic allocation of these network parameters is what DHCP is for. So that is what DHCP is used for. So let's now look into DHCP and see how it operates. So DHCP can be able to allocate addresses to end devices in one of three ways. So we have 3 ways in which DHCP can offer addresses to end devices. The first one is called manual. The second one is called automatic. And the third one is called dynamic. Now, in manual configuration, the IP address really is assigned to the client by the network administrator, by you, the network administrator. And DHCP is only used to handle the assignment of that manually defined address to the client. And really, what that means is, for example, here, now a few devices in your networks, like the server, like your servers and also your management equipment, network management devices, might need a more permanent IP address so that they are trusted, and you've configured other network equipment to be able to trust that IP address for security purposes. And server, because you want the same private IP to be always configured, to be always translated to the same public. So you want it to have the same IP address all the time. So for that, you configure an IP address manually on your server. So you configure in this server 192.168.1.1/24. Then now, in the DHCP server, you're simply going to exclude this IP address so that this IP address cannot be reassigned to any other client in the network. So that is what we call manual configuration. And that is the part that DHCP plays in manual configuration. Yes, you've been able to configure manually, but DHCP is still helping because that address cannot be assigned to any other person. Then the next one is what we call automatic. The second one is what we call automatic. Now, in automatic, you configure the DHCP server so that it will always assign a particular device a particular IP address. So, for example, your network management equipment, the computers that you're using to monitor the network, you can configure the DHCP server to always give it a particular IP address. So that is what we call automatic. Then the very last one is called dynamic. So these ones, most of the time, are for the users, people who need IP addresses temporarily, like students who are coming in with laptops, bosses who are coming in with tablets, and so on and so forth. So for them, you offer dynamic allocation. Dynamic allocation has a pool of IP addresses, and the IP address that is assigned to a particular device is assigned temporarily for a particular period of time. So those are the three mechanisms that are used by DHCP for address allocation. So let's move on. Now, DHCP uses several messages in order to offer a client an IP address. So these are some of those messages. So let's look at each one of them. Really, what you need to know about these messages is, number one, who is it from? And by that we mean, is it from the client or from the server? The other thing you need to know is what type of message is it? Is it a broadcast or is it a unicast? So these are some of the things that you need to understand. The other one is you also need to understand what it does. So what does that message do? Kazi yake ni nini? So that is what we want to see here. So let's begin with the DHCP discover message. The DHCP discover message. The DHCP discover message is a broadcast message that is sent by the client to locate the available DHCP servers in your network. So in your network, you can have one or more DHCP server. So that's why the discover is a broadcast. So immediately you connect your device to a network, and you select that it's supposed to acquire IP addresses through DHCP. It will send out a DHCP discover packet. That packet will be broadcasted in your LAN, and any DHCP servers will receive it. Now, once the DHCP server receives it, they'll reply with a DHCP offer. So the DHCP offer again is the DHCP offer is a unicast message that is sent to the client from the server. So the server is just replying, hey, I can give you the configuration parameters that you want. Then after that, the client now will respond with a DHCP request. The DHCP request can be sent out on several occasions. One of them is you are replying to the offer, and therefore you are requesting to use the offered parameters from one server and declining from all the other servers. So you've received offers from DHCP server 1 and DHCP server 2. So you send out a DHCP request, which is a broadcast here in this case, just telling the other guy that, hey, I'm taking parameters from server 1 and not server 2. like that. So that is the DHCP request. That's the first instance on which you can send a DHCP request. Let's look at the second instance. So you can also send a request as a client when you're confirming the correctness of the previously allocated address. For example, when you restart your laptop or your end device, so it will send out a DHCP request to confirm whether the parameters that it was assigned are still valid. So that's the other case. And in the next one here, the last one here, you can also send out a request when you want to extend the lease of a particular network address. You want to extend the lease. So as you're going to see, and as we said earlier, when DHCP server allocates IP addresses dynamically, they allocate them for a particular period of time. By default, it's actually 24 hours or 1 day. This value can be extended or decreased depending on what you want for your network as the network administrator. But in the meantime, when you want to extend the lease beyond that 24 hours, you'll need to send out a DHCP request. And we're going to look at that in the coming slide. Then, when you send the request, you can either get an acknowledgement or not acknowledged. So DHCP ACK or DHCP NACK. So the acknowledgement is used by the server, sent to the client, confirming that they can go ahead and use the network parameters that they have requested for. On the other hand, you can also get a NACK. So the NACK server indicates to the client that the client's requested network address cannot be assigned. Cannot be assigned. So for example, you've restarted. We saw here that you can restart your device. Then your device can send a request to confirm whether they can still continue using that particular address. So when you send that request, you can actually get a NACK if maybe your lease period had expired and the DHCP server actually assigned that address to another device. So you can get a NACK, not acknowledged. Then the last one here is release. So when a client is done using the network parameter, they can also tell the server that, hey, I'm done. So cancel the remaining lease. So yes, you're supposed to hold it for 24 hours, but I'm done with it within 3 hours. So just cancel the lease so that you can be able to issue it to another person. So DHCP release from the client to the server to relinquish the network address that it had been given. Then there's another DHCP message that is in the notes but was not captured here on this slide. It's called DHCP inform. DHCP inform message. Now, DHCP inform message is sent by the DHCP client to obtain other network configuration information, such as the gateway address, DNS server address, after the DHCP has obtained an IP, after the client has already obtained an IP address. So when you've obtained the IP address, you want to request for other configuration information, such as the gateway address, or you want to get the DNS server address. Then you send out a DHCP inform. This should be a unicast that is sent directly from the client to that particular server that has issued you with that IP address. So in total, how many DHCP messages? 1, 2, 3, 4, 5, 6, 7. So you must understand each one of them. Okay, so let's move on. So address pools. As we saw, in dynamic address allocation, we need to set what we call an address pool, a pool of address, an address range that we can give. Now, we have two general ways in which we can set or configure address pools. So the first one is called the global address pool. Then the second one is called the interface address pool. So you need to understand these two. Okay, so when you talk of the global address pool, we are configuring this particular address range so that it can be issued to all the devices that are connected to the DHCP server. So you see here, the DHCP server has two interfaces. These two interfaces might be on different network segments. So this one is on this network segment, this one is on another network segment. So when you configure on the global pool, for example here, we are configuring this address range. So from 10.2.2.1 all the way to 10.2.2.254. So when you configure that in the global, it means that host A, host B, and host A can each be assigned an address from this particular address range. So that is what we call the global, that all the interfaces, all the devices that are connected to that particular DHCP server can get addresses from the same pool. Then we have the interface pool. Now the interface pool is more specific in terms of only devices that are connected to that interface, network segment will be assigned that particular IP address range. So for example, the range here is 10.1.1.1 all the way to 10.1.1.254. So devices that are connected on this particular interface, all the devices, all the hosts, you'll have many hosts here, host A, C, D, blah, blah, blah. All of them are going to be assigned an IP address from this range. So that is what we call the interface address pool. Now, you can actually configure both the global and the interface address pool on your DHCP server. When you do that, the interface address pool takes precedence over global address pool. So even this DHCP server, you've configured a global address pool with that range, and you've configured an interface address pool with that range, then host A will be assigned from the interface pool and not from the global pool. So that's another thing that is important to understand. Now, when you talk of a DHCP server, the DHCP server might actually be, it might be a dedicated server, but it can also be your router. So for example, in Huawei, the AR2220 routers can also act as a DHCP server, and it can also be a switch. So for example, the S5700 Huawei switches can also act as DHCP servers. So it can be a dedicated server or a computer, a dedicated computer. Let me call it a computer. Can be server or a computer. So that's the other thing that is important to understand here. Okay, so when you look at the practical at the end of this, we are going to see the particular command that is used to select either the global or the interface address pool. So let's look at the DHCP process. So the very first one is what we call the DHCP address acquisition. So host A here wants to request for an IP address. Yes, Kichinda?
I didn't get the difference between the global pool and the interface pool properly. I don't know whether you can maybe clarify a bit.
Let me just try and clarify. So the global pool, what can I'm trying to look for something I can use to explain it. So in the global pool, you've configured the global pool in your server, in your DHCP server, so that anyone that is connected to that server can be assigned an address from that pool. And when you talk of a pool, we're talking of a range of IP addresses. So for example, in this example, our pool is 10.2.2.1 all the way to 10.2, our global pool, 10.2.2.254. You see? So when we configure a global pool with this range, we mean any device that is connected to this server can be assigned an address within this range. So that is what we call the global pool. Now, on the contrary, the interface pool, our range here is 1.1.1 all the way to 10.1.1.254. So only devices that are connected via this interface, only devices that have been connected via this interface can be assigned an IP from this range. Does it make sense now?
Yes,
so
it does.
host B cannot be assigned an IP address from this range because we've configured that as an interface pool on this interface. So that's the difference. That's the difference between the global and the interface pool.
Okay.
Yeah.
It's okay now.
Okay. So when you connect your device to the network, it will send out a broadcast packet known as the DHCP Discover. All the DHCP servers that are on your network will reply with a DHCP offer, which is a unicast. Then you'll now request to use those particular configuration parameters. The offer will come with the configuration parameters that you need. So then you'll request, and the DHCP request is a broadcast because you want to tell that, hey, I'm choosing to use DHCP server 1 and not you. Yes, I think 2 people raised their hand, so I cannot see your name. Just unmute your mic and go ahead.
This is Benson speaking.
Yes, Benson.
Yeah, I just wanted to ask about the global and the interface pool. Why should a host be given either a global or an interface address as in allocated from those?
Am I getting a question well? Go ahead again.
Because you're like a host can be given an address from either a global pool or an interface pool.
Yes.
So what determines that? That's what I wanted to know. Like, why should one be given either from the interface one or the global one?
Really, most of the time, it's a matter of what we call your design. You design your network, especially what you call the logical topology. That is how you're going to assign different devices IP addresses so that you can be able to configure what we call security through what we call access control lists. So, for example, let me give you an example. So, you want to configure these people that are configured, these people that are connected to this particular interface. You want to say that these are your staff. Then, these people that are connected via this interface, these are your students. Okay. Then, on the global, these are your visitors. So you want to give them a particular address range for each of this group for security purposes. So that's the main. So you usually, if you do HCIP, you learn how to design, how to plan your IP addressing, so that it becomes easier when you're filtering traffic using access control lists. So I don't know if that brings the point closer home.
Yeah, sure.
Okay, thank you, Benson. Okay, so I was here. After sending the request, then you'll get an acknowledgement from that server. Did someone else put up their hand? If you had raised up your hand, please put it down so that if another person raises up, I can be able to see their name. Yes, Moroa?
Hello, good morning, Teacher Karis.
Good morning to you, Moroa.
Okay, I have a small question.
Yes,
regarding the issue of global pool.
Yes.
Let's say, for example, a DHCP server has been configured to use the global pool.
Yes.
Then that server, it has been interconnected to two networks, just as the previous slide.
Yes.
So on the network address and the broadcast address for the two networks, how will they be allocated?
That's a tricky question. I'm not very sure about that. I'm not very sure about that for now.
Okay.
Maybe it's something we can look into and then try and reason out later.
Okay. Okay.
Aye. Okay. So we already talked of the acquisition. So we also have what we call lease renewal. Lease renewal. As I've said, the default lease period is 24 hours. The default lease period is 24 hours. Now, after, let me call it DHCP states. So, after your device is actually given an IP address, it enters into what we call a binding state. That is, imeshikilia your network resource, binding state. When it enters the binding state, I'm going to mention the other states, it sets three different timers. So the first timer is called the lease update timer. The second one is called the lease rebinding timer. Then we also have what we call lease expiration. So here we're going to look into lease update, the timer. So we've said this by default is 24 hours. Now, When 50% of the lease time remains, so if you're using the default, then that is 12 hours. The client should begin the renewal process. So how do you do the renewal process? You send a DHCP request to the server, to the specific server that assigned you that particular address. So if that server allows you to continue using it, the server will send you a DHCP acknowledge. DHCP acknowledge. When you get the DHCP acknowledge, you re-enter the binding state and you refresh your lease update timer. Because now this becomes like a new lease. So it goes back to 24 hours, for example, if you're using the default. Now, sometimes you might want to renew the lease, but the server actually sends you a NAC, not acknowledged. Meaning we cannot renew your time on this particular resource. When you get that, you enter what we call the initializing state. Initializing state actually is where you begin from when you don't have an address completely. So you have to send another DHCP request, which is a broadcast, so that you can reach all the DHCP servers that are there. So the initializing state. Okay. So let's see what we call rebinding expiry. Rebinding expiry. Now, rebinding will occur if the lease is not renewed in time. So what is that? At 50% of the lease period remaining, you send out a DHCP request, which is a unicast. But the DHCP server does not send you an acknowledgement or not acknowledged. So it does not reply. Maybe it's down. So maybe the DHCP server is dead. So when you get to 12%, 12.5% of the lease period remaining, you will begin the process of acquiring another IP address. So you send a DHCP request, which is a broadcast, so that any other DHCP server can allocate you a particular address. So that is what we call the rebinding process. Now, when you send that, for example, if this server is on, this server can actually reply with an acknowledgement or not acknowledgement. So for example, it had gone down, but now it's on. When it receives that, it's gonna reply with an ACK or an ACK. Of course, when you get an ACK, you go back to the initializing state. You go back to the initializing state and you immediately stop using that IP address. So you have now to request for a new IP address if you get an ACK during the rebinding. Okay. Now, when a client is done using a particular resource, they can also relinquish it, release it by sending the DHCP release message. Hey, I'm done. I'm done with this address, so that it can be used by other devices. So when you send a release, you must immediately stop using that particular address and go back to the initialization state. initializing state. So let's see how we configure the DHCP server to offer addresses on the interface pool. So here we are on this DHCP server. So the first thing we need to do is to enable DHCP. We always call this on the global. Whenever we are enabling any protocol on system view and not in a particular interface, we always say we are enabling it on the global. So we enable DHCP on the global. Then we get into the interface G001. Then we use the command DHCP select interface. So if we wanted to use DHCP select global, DHCP select global is the command that can be used to configure global address pool. But here we are selecting interface. Then, other than the IP address, we want it to give this IP address as the address of the DNS server. So the command is DHCP server DNS-list 10.1.1.2. So that is the address of the DNS server. Then we want to exclude the address of the DNS server so that it cannot be issued out. So the command is DHCP server excluded IP address. Then we specify that address. Then after that, we want to change the lease period from the default 1 day to 3 days using this command, DHCP server lease day 3. So we've changed the default lease period there. So DHCP configuration validation, we can use the display command. How? So display IP pool, then the interface name and number. So we can see the pool name there. We can see the lease period. We've changed it from 1 day to 3 days. We can see the DNS information. We can also see the gateway and the mask. At the bottom here, we can see the start and the end of the address pool. We can see the total number of addresses we have in that address pool and what has already been used, which is actually the address of the gateway, 10.1.1. You can also see things like those ones that are idle, whether you have any conflict, and so on and so forth. Okay. So we can also configure on the global pool. So how do we do that? On that server, again, we enable the DHCP on system view. Then we create the pool. So here you have to create the pool using the command IP pool, then the name of the pool. So for example, here we are calling it pool 2. Then it will get you into that pool 2 view. Then you can give it the address range that you want to give out using the network command. So network, then 10.2.2.0, mask 24. So the address that it's going to allocate is between 10.1.2.2.1 all the way to .254. Then this is how you specify the gateway address. So using the command gateway list, then 10.1.2.2.1. So that is the address of the gateway. Then this is how you do the list day. So here we're just leaving it to 1 because that's the default anyway. So list day 1. Then after that, you can go now to a particular interface. You can go to a particular interface, and this time you use the command DHCP select global. So this interface G001 is going to assign addresses from the global pool. From the global pool. So I hope that is clear. Is that clear, ladies and gentlemen?
Yes.
Yeah.
Okay, let me ask something.
Please go ahead.
In that DHCP server, I can decide to configure both the global DHCP
and
global
interface.
pool and interface within
Yes.
the same server.
Yes.
Okay.
When you do that, the interface pool will be preferred, will be used in favor of the global pool. Is that okay?
Okay.
Okay. So back to the question that Benson had actually asked. If you've configured a global pool on your DHCP server, how will these other guys on different network segments, how will these other guys on different network segments be able to communicate with the DHCP server? So actually the answer is you'll have to configure what we call a number of gateways. So you see here, we are configuring a gateway and we're just configuring one gateway. So when you want to use the global pool on different network segments, you have to specify different gateways by separating this list with a comma. So for example, your first gateway is 10.2.2.1, comma. The next one is from a different network segment, maybe 10.3.3.1, maybe 10.4.4.1, comma, comma, like that. So in the gateway list, that is where you specify the different gateways that those other devices can use. And you can also be able now also to specify the different network ranges for each of those network segments. And on that, you need to know that a maximum of 8 gateway addresses can be configured. A maximum of 8 gateway addresses can be configured. So I hope you're answered now, my friend Benson.
Yes, please.
Okay, so we can use the command display IP pool to see what we just created. So we can see the pool name is pool 2. We can see that we specify the gateway and the mask. And here we can see the statistics, total, used, idle, expired, conflict, disabled. Yes, Lynn?
I have noticed that the gateway address is a class A address, but the mask is for class C.
Yes,
what is that supposed to mean?
That is just supposed to mean we've done that is supposed to mean that we've done VLSM. You remember VLSM?
Oh, yes. Okay.
Okay, so we are done with this topic. So which IP address should generally be excluded from the address pool? Which IP addresses should generally, yes?
The one that belongs to the server.
Yes, for the servers, like the DNS server. Okay, which is the default IP address list period?
24 hours.
Exactly. Asanteni sana.